So I just wanted to make a couple of comments regarding this experiment that we covered in one of our recent videos. I have an n equals 5 Poncelet family inscribed in a circle and circumscribing an ellipse where one of the foci of this ellipse coincides with the center of the outer circle. And a remark we made was that um, let's see here. The remark we made was that yes, so the midpoints of the 5 diagonals, right? So if you take out of these 5 lines that comprise this polygon here, you take them 4 at a time, you can get 4 complete quadrilaterals. And the remark we had made was that the intersection of the diagonals of each one of those complete quadrilaterals, the main internal diagonals, they were concyclic, so they lied on this curious red circle. Okay, you can safely ignore these axes here. They're just a byproduct of the way this circle is being estimated. I'm actually estimating using least squares. I'm estimating a conic that passes through these 5 points, and then least squares is telling me that the ratio of the axes of this conic is basically 1.00000. Okay, so this is a mysterious phenomenon, why these diagonals must meet at 5 concyclic points, right? And then I had also said that we're getting this other phenomenon where the outer, if you just, I'm going to leave a link in the description, but you can go back to the video and recall that these were, yeah, so these outer points here were being computed as dropping perpendiculars from a specific internal one onto that outer diagonal. So here you got L1 prime. Now I wanted to just make a couple of remarks here. First of all, this is truly a circle, so numerically it's a circle. And I'll show you guys a second phenomenon that kind of confirms it. And the fact that the green ones are also a circle is kind of a corollary of the fact that each one of the complete quadrilaterals, so let's show one of them here. So here's a complete quadrilateral P1, P2, P3, P4, and then closing on onto P1. Because this quadrilateral too will be circumscribing or be circumscribed by a circle, by this black circle, it turns out that the construction for the corresponding L1 prime, okay, is akin to the inversion of each one of these red points with respect to this outer circle. Okay, so Arsenia Koken reminded me of this. So to make a long story short, these 5 points out here are inversions of these 5 red points with respect to this black circle. Since I'm claiming these are on a circle, inversion with respect to a circle preserves circularity, right? So these 5 points are also going to be taken to a circle. So it's sufficient for us to prove that the 5 red points are in a circle, and then the outer phenomenon falls from that. Okay, now this is still unproven. Now I want to just show another setup here that lends credence to this phenomenon here. And what I did was, I'm going to replace this caustic. So what's special about this caustic here? It is an ellipse, and it has a focus coinciding with the center. So what if I, instead of drawing an ellipse, I drew a hyperbola? And I did do this in GeoGebra. Let me go ahead and show that. So I just did this numerically or by hand, if you will. And here's an n equals 5 Poncelet family, still inscribed in a circle, this black circle over here, but now circumscribing not a semi-confocal ellipse, but circumscribing a semi-confocal hyperbola. And I just did this by hand. I did all the adjustments by hand numerically until I could actually close the n equals 5. And this is a little bit of a pesky family. It's not very stable. Okay, if this thing passes certain limits here, this thing disappears. But let's just focus on this particular area of the family. And then what I did was I intersected the diagonals of each one of the complete quadrilaterals, and I'm showing them here. And lo and behold, they're falling on a circle. How do I know this is a circle? Because I'm asking GeoGebra, I'm fitting a conic to these 5 points here, and I'm asking it to report to me what the semi-major axis length is. It's 0.1002947.803, and what is the semi-minor length, and you get the exact same number up to a large number of that. I think that's 10 decimal places here. So I'm convinced that there's really a phenomenon here, and all we need to prove is that these 5 intersections do fall in a circle. Okay, see you on the next video. Thank you.